You also want to make sure, I think that's it for wood, isn't it? Moves into steel. You're also going to need, oh, where is this? I know I should have bookmarked it. Sorry, I didn't write this down. I knew I should have. Page 32.
What do you have inside trade?
Make sure to bookmark page 32 when you flip to that. That gives you a bunch of different minimum floor live loads. I don't know why they didn't just throw that in an appendix instead of throwing it within a chapter. That'll be something that you'll need to reference. So, the design constraints that we have to think about, our house is in a mountainous region. With hot summers and cold winters. So, we haven't talked about insulation to this point, but what should that be telling us when we're thinking about making a home?
R49.
What's that?
High insulation levels, high R levels.
Yep. And so how could we get more insulation in on that exterior wall?
Thicker wall.
We could use a thicker wall, right? Use 2x6s instead of 2x4s. Okay, so
it's just telling you like uniformly distributed loads, but what the hell is that?
yeah, we won't have to think about it specifically with respect to this problem.
Okay.
But when we look at the steel and concrete construction,
Okay.
that's when we're going to start moving into some commercial and some larger type buildings. So make sure that you got that bookmarked.
Sure.
We'll need that for calculations.
So
Okay, so
we need 9 quarters and 10.
so the
So
general
we-
layout
8-inch nominal beam depth.
of the home, how's the scale? Scale's pretty atrocious.
That's 6 inches because it's less than 9. For the floor joist, right? Or we're doing roof.
Yeah, but look at the beam span. A 2x6 can go 9 feet on the floor and 10 feet. So I'd put it in the second column.
Yeah. Well, wouldn't it only be in 10 feet or the roof joist could only be the 8-inch nominal beam depth. Technically.
What's that little symbol mean? Is that greater to and equal to, or greater and equal to?
On the right.
On the span 9.
Span 9 is less than span.
It's less than
9
or
is
equal
less
to,
than
right?
span, or less than equal to 13.
So are we just doing floor joist right now?
No, we're not.
What's that?
Well, for
But you gotta figure out where to put
We're gonna
the,
look at everything.
Well, yeah.
Well,
you
not,
can-
sorry, not everything. We're going to
Well,
look
because
at.
like you can do 2x6. Well, for the 2x6, like the floor joists
Mhm.
have a different depth than the roof joist.
Yep,
So
yep.
that's what I was wondering.
Yep, that's what we're gonna look at. That's what we're gonna look at.
fuck you.
Camera running.
Sorry.
Right?
Okay, so our general dimensions, so we have 28 feet by 50 feet, okay? So, when we think about residential construction, our structural systems, what are they going to be combined of? What's going to make our shear wall?
Studs.
and
Sheeting.
our sheathing, right? Our sheathing is going to act as our shear wall, okay? So, but we also have this section of the wall, which conveniently is running on center, down the middle of the house, okay? So we need to determine, do we have sufficiently sized diaphragm? Are we going to need additional shear wall down that middle, okay?
Okay.
And what's that ratio?
See, that makes more sense.
1 to 3, right? So all you need to do, you have 28 feet. Sorry, just for ease, we'll say that that's north. So 28 feet running east to west and 50 feet running north to south.
That's like less than 1 to 2.
So it's, yep, it's about 1.22, something like
Sure,
that.
Yeah.
But less than 1 to 3, right?
Yeah.
So we're good. So we don't need any internal shear, okay? So what does that tell us that we can do with all of our internal walls? Disregard them from shear, right? Okay, so we're just gonna use 2x4s
On
at
the
that
inside.
point. On the inside, yep.
So-
2x6s on our exterior walls, right?
Okay.
Okay? Oh, shoot, I need to put up, this was there too.
Good old people.
Okay.
What is that?
So we're gonna have 2-story, there's gonna be an unfinished basement,
Just open?
yep,
But it don't matter if it's all open, because we already figured out the footprint's good, right?
correct,
Okay.
yep. And then this is gonna be our main floor as drawn.
So if you look at the table on 168,
Yep,
it gives you your lumber size in inches and then your maximum spans for floor joists and roof joists. You're saying 2x6s will be our studs?
2x6 will be the studs.
So does that have a limit? You know, because aren't these joists, aren't they talking about what runs laterally through?
Spans.
For your floors.
Yeah.
Yep. What do you mean for limits?
Well, so does a 2x6 say, hey, can we
Oh.
go 19 feet up with a 2x6?
Well, and that gets back to, remember what we talked about last semester. What did we talk about last semester in the different
Framing,
style of
balloon
framing?
Like, yeah.
If it goes all the way through.
Yep.
Yeah.
Yep, so, I mean, so I guess you could, if what you want to do is get 19, or are you asking more for determining the shear wall?
For the size. Do we gotta move up a size to like 2x8 because, oh, we can't go 10 feet with a 2x6?
Something like height restrictions
Yeah.
on the sizes of your studs.
Oh, I see what you're saying. For the purposes of this problem, outside of scope.
Okay.
Now we're talking about building code, right?
Okay.
We're talking about building
Well, because
code.
it's giving you restrictions for the choice. So I was just wondering, do the studs get restrictions too?
You'll have height restrictions by code. Yeah, the IRC will have height restrictions. I don't know what they are off the top of my head. I'm not as familiar with the residential code, so.
Alright, cool, let's do the problems.
But
No
for-
idea what we're doing.
For the purposes of this, no, we don't have to worry about it.
Okay.
Okay? We should also keep in mind, what about our shear wall? Okay, so on the main floor, we've got a 10-foot distance, right? So our 10-foot to our 28-foot. Isn't going to be an issue, right? It's 1.2, 1 to 2.8. So that's good.
The 50 foot.
That one's rough, that was 1.5.
That's gonna give us a problem, right? Okay?
Well, yeah, but there's only one of those.
Well, it's gonna be
Well, there's gonna be a 75.
on this side and that side, right?
Well, that one only goes up, dips in, and
Yep,
so that doesn't break up.
yes, yeah, good point. Yes, on this side, you have a break from your foyer.
Yeah.
Yep, yep. So yeah, just on our west wall as drum is where we're going to have an issue. Okay? So we'll need to use something intermediately here, okay? And don't worry about that at this point, we're just gonna blow through this. Chapter 4 is just kind of introductory structural systems. Once we get into the wood construction later in the semester, we'll talk about how to specifically deal with that. Okay? So, we've looked at our diaphragm, we've looked at our shear walls. Talked about, okay, so how about support for our beams?
Gosh,
Okay, so table 4.2.
No structural engineering, sorry.
4.2.
What's your question?
Well, we're just curious, like, what would you have to add then for that shear wall? Obviously, it's
You
a
just have to have
1.5.
some sort of break.
So would it be
You just want to break
a
it into two
beam going
systems.
vertically or a beam like for bracing or something?
What's that?
No, he was.
Yeah, we'll figure it out later.
Yeah, yeah. You just want to you'd want to have some sort of vertical break. Is all that you need.
I would.
Okay. So when we look at table 4.2. So our approximate depth for our wood beams. So what are we looking for our span?
No beam, like 6 inches, 9.
6 inches.
Span is less than or equal to 9 feet. So we need a bigger, right, bigger span than that, obviously. 14 feet is what we're looking
14 feet, right?
for. Yeah.
Okay. So what size would you need? Pulling it out of the table.
Ten.
Floor.
10
What's
inch.
that?
Ten with the cylinder floor.
Floor.
Ten
What I
inch.
was asking before.
No, very nice.
Yeah.
That's true. Yes. That's true.
10 inch, right?
For the floor?
Floor will be redesigned.
We span greater
What's
than
that?
13.
The floor will be redesigned.
Yes, exactly, exactly. The preliminary design will not be used. So what they told us to consider is to consider that they would break it up into 3 bays essentially. Okay, 16 feet 8 inches. So that puts us where? Here and here.
It's still the same.
Okay.
13, 17,
10
10 inches.
inches. 10 inch nominal beam depth.
And then for our
Huh? It's going up there.
and if we're setting floor and roof joists at 14 feet
10 inch.
for which one? Don't you have a difference?
Oh, are we doing 4.1 now?
Yeah, joists are in 4.1. So what is your floor going to be sized at?
2 by 10.
2 by 10,
2 by
and a
8.
roof
2 by 8.
at 2 by 8. Okay.
What are these 2 by 6s?
Yeah, that's what.
Those are stilts, right? Two by sixes are our exterior, look at, use two by
I
sixes.
see that.
They want to look at the possibility of 2x10s for the roof in case we need extra insulation. Okay, again, if that's going to be allowable, that's always going to be a big concern for us. Steve?
So, the way it's drawn, there's a bedroom in the attic, so
Yep.
to speak. So the joist that they're talking about for the roof joist, is the floor of the attic, or is it roof?
True roof joists. So there's got to be something.
That's fine.
Up
I
above
want to
that bedroom,
clarify
right?
what they're talking.
Yeah.
Which would bring me back to the 14-foot span for the,
Yep. Yep. So this would still be, if we're putting a bedroom here,
yep,
this is still going to be
Floor joist.
2x10 because that's a floor joist, right?
correct.
Yep. So.
Yep.
Now, I don't know, it doesn't, we don't see anything in plan for up here. Is it a bedroom that's 50 feet long? You know, I don't know, maybe it's half an attic. It's not very clear from the picture what's going on with it. Okay, let's see. We have 10 minutes left, so. Well, okay, so we've sized our floor joists, we've sized the roof, we've figured out our beam support. As Steve pointed out, we have to figure out what's going on truly in the basement, right? Do we have any sort of support? That thing just doesn't deflect and fall through. We know the size of our members for our exterior walls and our interior walls. Okay, so these are the types of questions that this chapter is asking to determine. We have to keep in mind that chapter 4 is just kind of laying out the 30,000 foot level for each of these materials. Okay, once we get through talking about this, we'll jump into concrete construction and start looking at these things a little more specifically. Okay? So does this type of problem seem reasonable from a homework assignment?
Is that the answer?
Well, you'd have this, right?
Okay.
You'd have your checks. And you'd have your sizes.
I
Okay?
think I like that a lot better.
Don't worry, we'll get back to more analysis.
See, I'm still stuck on bedroom.
So a shear wall, so you got the 50-foot wall on the backside of the house,
Backing it up.
and it exceeds 1 to 3? So that doesn't make it stronger,
What doesn't make it stronger?
then it's, for 10 feet height, it's 50 feet long, wouldn't that be stronger than if it's 10 feet high, 30 feet long?
It's not necessarily that we're worried about it being stronger. We're worried about how is it going to pick up that load and effectively distribute it. That's what we're concerned about. Think about when we were at Mall of America, Boy Scouts of America, and how they had the different bays. We're just going to want to look at, do we need to put in some sort of brake to help distribute that load? That's all that we would have to look
But
at.
it doesn't work, that if you spread it over a longer span, it's better.
Yeah, that'd be sick. then.
Don't spread what?
Yeah.
So it's lateral movement,
Yep,
19.
and if you're 10 feet tall, so to speak,
yep.
it's got X amount of,
Who's that?
Oh, I see what you're saying. Going to depend on your magnitude, right?
maybe I'm doing it wrong.
Who's that?
Going to depend on your magnitude. So,
My insider.
from the standpoint of residential construction, I wouldn't have any issue with it. I don't think that you'd have to
So
start
we've never
throwing
broke,
in.
I've never broke a wall. Well,
Yeah,
which is, we're back to this, who knows?
yep,
What we do is it's that every 20 feet, we gotta have a shear.
Sure.
We gotta have a shear panel, not
sure.
a shear wall. It's a shear wall, but it's gotta have a panel.
It's, okay,
If the wall is so long, it has to have a panel, and if it's over 20 feet, you gotta have a second panel.
and that might be a code requirement.
It is,
Some sort
I
of
mean, that's how
best
they
practice.
engineered it out
Sure,
to pacify this state code.
sure, sure.
I'm just getting confused as
Reel it
to,
back in there, Steve.
you in a hurry?
Huh? No, I was just stretching.
Just trying to clarify.
Yep. No, I think it's a good point. We have to keep in mind that these kind of general preliminary designs, it's more to give you a ballpark to estimate, right? To get you so you can start figuring out how much material we're gonna need, how can we cost this thing to figure out what's going to be the most economical way. This is by no ways and means a final design, right? Because once we get our preliminary design, then we can try and optimize. That- But yeah, as far as the difference between what the code allows and what a preliminary analysis, I don't know the residential code well enough to be able to say too much. From the standpoint of putting up a 2-story house
The labor.
and having a 50-foot wall, I'm not too worried, personally. You know what I mean? There's probably gonna be a deck out there, there's some windows, so you're gonna have some cavities.
Yeah.
That's the other thing is, you've got windows everywhere.
Yep,
So for shear wall, what we're supposed to try to meet is from the foundation to the roof,
mhm,
that shear wall, that panel.
yep,
So
would
I guess
be, should be
remember,
continuous.
It's 2 stories tall. You should take that 19 feet in. Oh, never mind.
What's the semester?
I keep looking at that, thinking that the 9 foot's the main floor.
I would think of, yeah,
She
your grade is probably,
Right.
you know, somewhere in here. So. But yeah, that, if we had a 2-story building,
The shear wall goes from the foundation.
the shear wall would run, yep,
It's tall.
yep, yep, and would fit within that 1 to 3 at that point, so.
So where we should be at?
Okay, well, rather than try and tackle steel today, as we only have 5 minutes, let's take a look at it on Tuesday. We'll look at steel and concrete. Should be able to wrap up chapter 4 on Tuesday. Okay, so, again, keep in mind that assignment, as soon as I get my computer situation figured out, I'll get that opened up. I'll change it. What's that? Yeah. Oh, yeah, I can, can't I? Absolutely.